Okay, so here we go, guys. All right, so essentially, guys, what I've got here is I've got a list 0, okay? And if I wanted to look at that list, my data would look something like this. I'm just going to write one little bit of data in here. The data in my list then, because I'm not working with any colors, working with the old school graphic capabilities here, would just be 0, 0, 0, 0, 0, 0. How many do I get? 1, 2, 3, 4, 5, 6. Two more. 0, 0. All right. All right. So that's what my list 0 would be, right? Right below that, I've got another list, right? So I would have my list 1, and then below that I have list 2, 3, 4, right, 5, 6, 7. All right, there we go. So there. Oh, it might be actually people walking around the street. I didn't think about that. Why is that? All right, so I've got 8 lists there, right? I end at 7 because I'm counting these the way a computer would. Okay. Now, what I could do is I could, write out each one of those lists and do it that way. Or what I could say is really what this is each one of those lists can fit in a master list. All right. So if I take all of these, I can lump this whole thing into a master list. Okay. And what my master list would essentially look like in code then is it would look like this. It would look like list 0, list 1, and on and on and on. Okay? Now, what I've done then is I've actually created one list that codes for, in this case, 8 other lists, each one of those representing a line in our pixel graphics. Okay? Now that's pretty handy because ultimately I could get any one graphic that I create, which we can call them sprites because in computer graphics whenever we have a little pixelated graphic, that's typically what we call it, right? So if I had Mario up there, Mario would be a sprite, right? If I had a Goomba or Pac-Man or the kind of classic Space Invader looking dudes, those are our sprites. Okay. Now the bigger my sprite, the more lists are going to be nested in my master list. But the beauty is once I get that master list, I can just call on that master list at any point and I don't have to like recode a whole bunch of graphics or anything like that, right? I can essentially make my pixel sprite one time and then just use it as many times as I want from there, right? Because I've created that master list. If I didn't create that master list to handle these, I could still code graphics, but it would literally require making lists every single time. Okay? So really what I want to understand is that we've essentially got a list within a list. So each one of those lists then will look different, right? So if I was looking at this one right here, that would be 0, 1, 0, 0, 0, 1, 0, 0, right? And this one down here would be 0, 1, 1, 1, 1, 1, 0, 0. Okay, so we put those things together and then we can kind of create whatever it is we want to create in there. In your NES system, most sprites were based on, I don't think sprites went bigger than a 16 by 16. And if you look at old Nintendo graphics, you can actually tell that everything is built on 16 by 16 grids. So that when you've got grass, or something like that, it's just the same grass block coded and then called lots of different times, right? And put into a grid format. So what we could really do then is say I was wanting to position these things on a grid. I could then put master list with inside an even bigger list, right? Like maybe I'd call it world list. And so I can just keep nesting these lists together and start populating my page with graphics. We're just going to stick with designing single sprites in here. And we're going to start off essentially today with working just with sort of this black and white system. Because adding color is going to require a little bit of extra work. Okay, this is fairly easy to do, right? So we could, code whatever we want. The reason I gave you that paper is so you guys will be able to design a little black and white sprite for yourself today. So, you could do something like this. If you wanted to make like a face. So anyway, you can just color on here. And later when we do color, like I said, it'll get a little more complex. But, this looks like a Space Invader kind of guy. Kind of does, doesn't it? I don't know how you would want to do it, but it does look a bit like Bomberman. So anyway, you can make up whatever you want on there. Okay. So today for our assignment, I would go no bigger, even though I gave you much bigger grids. I gave you a 16 by 16. I'd go no bigger than an 8 by 8 for our assignment, because you'll find out that we're going to have a big enough project when we start designing a real, sort of nice pixel graphic. We're going to have a big enough project when we, you're going to be very annoyed at writing list of 16 characters, right? That's quite a lot. 16 lists, 16 characters. So there's a bunch going on there. Okay. So now we're gonna go ahead and go to the computer here. So open up idle, guys, and we're really just gonna do a bit of practice. So I'm not gonna put on the big, like the assignment list and everything like that. We're just kind of going through some theory here. So let's get that going. What I really want to show you first off today, guys, is how we put a list within a list, and it's fairly easy. But there is one little sort of nuance that you really got to pay attention to. Okay. All right. So once you got idle open, you don't have to worry. You might just hashtag put your name in there or something like that. And we're just going to title this thing our sort of our list test. So what I'm going to do here is we're going to use a very basic code so we can kind of prove or show you the theory before we start adding everything else in. Okay. So what I'm going to do, guys, is I'm going to start off with a list called pixels. Okay. And I am going to set that. I'm going to define my list, so to speak, here. So I'm going to use a square bracket. Okay. And I'm going to use, let's keep it really, really simple. Let's just use 5 items in there. Okay. Ones and zeros for now, but you'll see that we don't have to just use ones and zeros. We can use other numbers to specify like the colors of pixels and stuff like that. But I'm going to use ones and zeros. So I'm going to say 1, 0, 0, 1, 1. Okay. And then I'm going to finish my list. Okay. Now, if I wanted to, and you guys don't have to do this here, I could print off my pixels and what I would see. And so I'm going to have to save this thing as something. So I'm going to call this just a pixel test. Okay. And there we go. There's my list. Okay. And so that could be like, essentially one line. If I were, writing this on my little page, I would darken in my first little square, skip 2 squares, and darken in the second 2 squares, right? That's not going to be a very interesting set of pixels or a very elaborate drawing, but it is something, right? Now, the problem is if I want to make my next line, what I would have to do is make essentially my pixels line 2. So I could say there's pixels 2. And then I could say, okay, I'm going to go on this one 0, 0, 1, 1, 1, right? And all of that. And then I could say, oh, well, here's my master list. And my master list consists of pixels and pixels 2. But that gets to be a whole lot of writing, okay? So I'm going to tell you this is the wrong way to do it. It works, but it's not the best way to do it, right? We want to try to think as much like computer scientists as possible, not super parsimonious here, okay? And I can, in fact, shorten it down and do something else. So let's just say then if and watch what happens, guys. If I print my master list, I'm not actually going to get what I want, right? There it is. So there's my original list, and there's my master list. It's a list with 2 lists in it. But if I were coding that in graphics, I wouldn't really want that to be the case. I would want this to appear above this, okay? So that's a bit of a problem. So here's what we're going to do instead. We're going to make a new list here, okay? And say I need a new name. Well, let's just shorten it. Let's just call this the pix, okay, instead of writing out the word pixels. And let's make a list out of this using the same kind of ideas we did before. I'm going to say this is 11101. Okay. And you can put in whatever you want here, guys. Okay. And what I'm going to do instead is I'm going to actually double bracket this with square brackets. Okay. I'm going to put a bracket here, and I am going to put a bracket here. What that means is pix actually consists of a list 11101 inside a list. So right now it's a list of 1 item. Right? I can prove that by say print the length of pix and do that. And see, it says the length of pix is 1. And that's actually what I want, because I want that to be the first item in essentially my master list. And really what I'm doing here is I'm creating a master list without actually naming anything master list. Okay, so now what I want to do is as follows, okay? And you'll see why we do this as well, because pixels 2, that gets really, really confusing. And what we want to do is we want to essentially write a code where we can sort of visualize what we're making in the process. Okay, so here's what I'm going to do, okay? I am going to write this. I'm going to say pix dot append. Aha, append is coming in. Where does append go, guys, when I append a list? What's that? Goes to the end of the list. All right, so here's what I'm going to do now. I'm going to use my, whoops, not a 9, my parentheses, okay? And I'm going to append that with a brand new list that I'm going to insert inside pix, right? So I can put whatever I want in here, 0, 1, 0, 1, 1, square bracket, and finish with my parentheses. Now, here's what I would like for you guys to do, because this will actually make things really, really nice for you, is at this point, this pix equals, it doesn't matter how many spaces I have between them. Python can read it just fine. So watch this. If I tab this over or space it over like that, now look what happens. I'm actually in my code itself, I'm starting to see the picture I would be forming, right? Because in my final product, what I'm going to see is I'm going to see a 1 with a 0, or in this case, a pixel, right below it, no pixel. Here, I would see a pixel, right below it, a pixel, pixel, no pixel, no pixel, 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 pixel. So I'm actually in my code itself going to be able to sort of see what it is I'm drawing. Now, you'll see that once we add color and stuff, it gets very difficult to actually see what you're drawing, but it does make life a whole lot easier than listing everything as a list, because I can catch errors easier in this, okay? So what's beautiful then is I don't have to keep writing new lists. I can just keep appending my current list. So for example, I can say pix.append, all right? And then I can go ahead, whoops, put my parenthesis, I can't do a parenthesis, put my parenthesis, put my square quote, and say this time I'm going to go 0, 1, 0, 0, 0, and 1, okay? And finish that off. Okay. All right, now I'm going to show this in a sort of weird way, something for you here. If you want to, you could go ahead and print out pix just to see what it looks like, and you're going to see what it looks like is still not very pretty. It's just 3 lines, right? 3 things in the list there. And that's actually the point of writing it this way, is because the computer is essentially going to read things this way. But this way, it's very hard to see what your picture would be. And this is really done for the humans doing the coding. It's a lot easier to see what my picture is going to look like, okay? What we have to do is specify, how it's going to read that list to actually be able to output those different lines and whatnot, okay? So let's write a little loop here that could do something with this, okay? So here's what we're going to write. I'm going to say for I in range. And I don't know what range I want because I don't know how many things is on my list. So I'm going to say the length of pix. Okay? So for I in range, length of pix, whatever that could be, put my colon in there. I'm going to print, let's do this. Let's print pix I. Okay? So that means for 0 in range of pix. So in this case, pix is going to be 3 things. 1, 2, 3. Okay? I could actually prove that by printing the length of pix over here. There it is, 3 items. And oh, and then it ran my loop. Now, do you see what happened when I ran my little loop then? How does that look? It's starting to look like something, right? I could use asterisks and blanks and stuff like that if I wanted to actually print out a text picture. You can use this to actually make ASCII art, by the way, for those of you who, if you know what ASCII art is, you can totally do ASCII art in this form, okay? So I printed my length of pix, and there we go. There's my list. All I had to do was write this one for I in range length of pix. Length of pix was 3. So for 0 in that range, I'm going to print out list pix item number 0, which is the first thing I put in there, right? Then it's going to go through for 1 in the range of 3. It's going to print out the fix item number 2, which would have been what we appended in there. Okay? Does that sort of make sense to you, what we did there? Yeah. Well, yeah, we're going to put it into something so we can actually draw a picture, right? Yeah, we need to do that, of course. Right. And, it can be as elaborate as we need it to be. But that is sort of the theory behind it. Right. I just wanted to make sure we understood, because when I start doing things and it's going to get very complex when we start to actually make our graphic, because there's 2 graphics programs essentially that are sort of we can import in, and we're going to use the one that we're used to using, which is Turtle. So we're going to do it in Turtle. Okay. So we're going to make our graphics in Turtle. And the curriculum that we're running off of, the JVC, that's the way they do it too. That's what we're going to do. Okay. All right. Okay. So do you want to do that? All right, so you might just save that as something and go ahead and let's start anew here. Okay, and I got to watch our time here because we have 8 minutes. Oh, then we don't have time to even get into it. That's where we're going to stop it for this.